You're refilling the bird feeder in your backyard. A small sparrow lands on the edge, watching you from a few feet away, head tilting side to side. You barely think twice about it. Just a bird, doing bird things. Except that sparrow is, technically, a dinosaur. Not a metaphor. Not a loose comparison. Birds are classified as living dinosaurs, direct descendants of a lineage that never actually went extinct. Modern birds share a direct evolutionary line with small feathered theropod dinosaurs, the same broad group that includes Tyrannosaurus rex and Velociraptor. Strip away the feathers on some early bird ancestors, and the skeletal similarities to their non-avian dinosaur cousins are strikingly close. Hollow bones, similar hip structures, even comparable nesting behaviors preserved in the fossil record. So, in one very real sense, you already live on a planet where dinosaurs survived. But that's not the question everyone actually wants answered, is it? What people really mean is this. What if the big ones never disappeared? What if Tyrannosaurus rex, Triceratops, Velociraptor, the entire non-avian dinosaur world simply kept going, generation after generation, all the way to today? To answer that, you first have to understand exactly what almost erased them, because that event is far more specific and far more fragile than most people realize. About 66 million years ago, a piece of space rock roughly 6 miles wide slammed into what's now the Yucatan Peninsula in Mexico. The impact released energy equivalent to billions of atomic bombs instantly. But the initial blast wasn't actually the main killer. It was everything that came after. Geologist Walter Alvarez, along with his father, physicist Luis Alvarez, first proposed this impact theory in 1980 after discovering an unusual layer of the element iridium in rock formations worldwide, an element rare on Earth's surface but common in asteroids. That thin layer, found at the exact geological boundary marking the end of the dinosaur age, became one of the most important clues in paleontology. Sounds like solid enough evidence. But how does one impact wipe out something as dominant as the dinosaurs? The impact triggered a global cascade, massive wildfires. Tsunamis hundreds of feet tall, racing across entire ocean basins. Then, crucially, enough dust, soot, and sulfur got thrown into the atmosphere to block sunlight for months, maybe years. Photosynthesis collapsed. Plants died first, then the animals that ate them, then the animals that ate those animals. It wasn't really about size or strength. It was about how quickly a species needed food, and how flexible its diet actually was. That single detail explains an enormous amount about who actually survived. Small, adaptable creatures that could eat seeds, insects, or scavenged scraps made it through the collapse far more easily than massive herbivores that needed enormous, constant volumes of fresh vegetation, or apex predators that depended on a steady supply of large living prey. Geologist Jan Smit, whose research helped confirm the Chicxulub crater itself as the actual impact site years after Alvarez's original theory, has described the extinction less as a single dramatic moment and more as a rapid ecological unraveling, one broken link in the food chain, pulling down everything connected to it within just a few catastrophic years. This is exactly where the story usually gets it wrong. So let's pause here. Now imagine a version of Earth where that asteroid missed. Not by much, just enough to skim past instead of colliding directly. No iridium layer, no mass extinction event. What actually happens to the non-avian dinosaurs from there? Paleontologist Steve Brusatte, who has spent his career studying dinosaur evolution and diversity right up until the extinction event, has pointed out that dinosaurs weren't some primitive doomed group patiently waiting to be replaced. They were still diversifying rapidly right before the impact, evolving new body types, new feeding strategies, even complex social behaviors. Brusatte's research into late Cretaceous ecosystems found healthy diversity across multiple dinosaur groups, right up to the boundary layer itself. Horned herbivores, duck-billed grazers, small feathered predators. all coexisting in complex, functioning ecosystems. There's no strong evidence they were already in decline. If anything, the timing of the asteroid was almost cruelly specific, arriving at a moment when dinosaurs were still thriving, not fading. So if they kept thriving, uninterrupted, for another 66 million years, what would they actually look like today? Here's where things get genuinely strange, because evolution doesn't just mean the same animals, but older. 66 million years is an enormous span of time, more than enough for entirely new dinosaur lineages to emerge, diversify, and go extinct on their own, the same way countless mammal lineages have risen and disappeared since then. Paleontologist Dale Russell once proposed a famous thought experiment based on Troodon, a small, unusually intelligent dinosaur with relatively large eyes and a brain size proportionally larger than most of its contemporaries. Russell speculated that, given enough additional evolutionary time, a Troodon-like lineage could have developed increasingly complex cognitive abilities, potentially even something resembling tool use. His proposed result, nicknamed the Dinosauroid, was an upright, large-brained, vaguely humanoid creature, more speculative art than rigorous prediction, but grounded in a genuinely interesting biological question. Was there evolutionary pressure already pushing some dinosaurs toward greater intelligence? Most paleontologists today view the specific Dinosauroid design as overly speculative, criticizing it for assuming evolution would inevitably converge on a human-like body plan simply because intelligence increased. Bipedal, forward-facing eyes, grasping hands, that particular combination isn't guaranteed just because a brain gets bigger. But the underlying question still holds up. Some dinosaur lineages were already trending toward larger brain-to-body ratios before the extinction event cut that trajectory short. Whether that trend would have continued for another 66 million years, plateaued, or reversed entirely is something no one can actually know. Evolution doesn't move in straight lines toward a predetermined destination. It responds to whatever pressures a changing environment happens to apply, generation after generation, with no long-term plan attached. There's another wrinkle worth considering, too. 66 million years without a mass extinction doesn't just mean more dinosaurs. It means an entirely different Earth. Flowering plants, which were still relatively new and spreading rapidly right before the impact, would have continued co-evolving alongside whatever herbivorous dinosaurs ate them, possibly producing plant life unrecognizable compared to what actually developed under mammal-dominated grazing pressure. Climate patterns, shaped over millions of years by which species dominated which ecosystems, could have taken an entirely different path as well. A surviving dinosaur world wouldn't just be today's Earth with bigger animals wandering around. It would likely be a fundamentally different planet, shaped by 66 million additional years of choices evolution never actually got to make. But here's the twist most people never consider, the one that actually reframes this entire question. If non-avian dinosaurs had survived, there's a strong chance you wouldn't exist to ask about it. For the roughly 165 million years dinosaurs dominated Earth, mammals stayed almost uniformly small, mostly nocturnal, mostly rodent-sized or smaller. This wasn't necessarily because mammals were biologically inferior. It's because dinosaurs had already claimed nearly every large-bodied ecological niche available, and competitive exclusion, the principle that two species can't indefinitely occupy the exact same ecological role, kept mammals boxed into the margins. Fossil evidence from that entire span shows mammal body sizes barely budging for well over 100 million years, generation after generation of small, cautious, mostly nighttime creatures, essentially wading in the shadows of animals many times their size. Broussate's research into the aftermath of the extinction event shows just how quickly that changed once the dinosaurs were gone. Within a few 100,000 years, an extraordinarily short window in evolutionary terms, mammal body sizes exploded. New lineages emerged rapidly, filling niches that had been unavailable to them for well over 100 million years. Some grew to the size of small cars within just a few million years of the extinction event. An almost unbelievable pace of change once the ecological ceiling mammals had lived under for so long simply vanished overnight. That opportunity, not some sudden mammalian superiority, is what eventually led toward primates, and eventually toward you. So a surviving non-avian dinosaur world doesn't necessarily mean humans exist alongside them. It might mean humans, or anything resembling us, simply never evolve at all. Try sitting with that for a second. Your entire existence may hinge on a 6-mile-wide rock arriving at almost exactly the right moment, in almost exactly the right place, 66 million years before you were born. Not a slow, gradual replacement, not dinosaurs peacefully stepping aside once their time was naturally up. A single, catastrophic afternoon that happened to clear just enough evolutionary space for a small, unremarkable group of shrew-like mammals to eventually, after tens of millions of years and countless intermediate species, become you. This is where the story stops being about dinosaurs at all and starts being about something much bigger. How much of life on Earth, including your own life, depends on pure evolutionary contingency rather than some guaranteed forward march toward intelligence or complexity. Paleontologists sometimes describe this using a phrase borrowed from evolutionary biologist Stephen Jay Gould. Replay the tape of life, and you might get a completely different outcome every time. Gould used this idea specifically to argue against the comforting notion that evolution was always somehow building toward intelligent life, toward something like us, as an inevitable destination. Change one variable, one asteroid's trajectory by a few seconds, 1 degree of angle on approach, and the entire 66 million year story that followed, mammals, primates, humans, civilization, may never happen at all. It's a strange kind of vertigo, realizing that the single most important event in your species' entire origin story was, as far as anyone can tell, pure chance. So the next time you glance at that sparrow on your bird feeder, you're not just looking at a distant dinosaur descendant. You're looking at the branch of that story that actually survived, small, feathered, warm-blooded enough to make it through catastrophe, while its larger relatives quietly ran out of time. Every other branch, the massive predators, the armored herbivores, the almost intelligent little hunters Dale Russell once imagined evolving further, all of it stopped permanently on one catastrophic afternoon 66 million years ago. You're refilling the bird feeder again tomorrow morning. The sparrow returns, same tilt of the head, same brief pause before it eats. Except now you notice it a little differently. Not just a bird. The dinosaurs never really disappeared. They just got small, grew feathers built for flight instead of display, and learned to survive on backyard bird feeders instead of ruling continents, waiting out the rest of history one quiet, ordinary morning at a time.